Did you know NASA has actually researched technology straight out of Star Trek? Not fiction, not a novel, but real science. It's called warp drive, an engine that bends space itself. Sounds insane, right? But here's the strangest part. The theory has existed for 30 years, and now scientists are trying to make it real. 1994, a Mexican physicist named Miguel Alcubierre. He was working on his PhD at the University of Wales one day after watching Star Trek. He wondered, could warp drive actually exist? The idea seemed impossible. Everyone knew Einstein's speed limit. Nothing with mass can reach the speed of light. But Alcubierre was curious. He asked a different question. What if we don't move the ship? What if we move space itself? So he started calculating. After a few months of research, he discovered something unexpected. Einstein's equations allow for this. Warp drive does not violate physics, at least not in theory. He published his paper in Classical and Quantum Gravity. The title, The Warp Drive, Hyperfast Travel Within General Relativity. But wait, didn't Einstein say nothing can travel faster than light? Yes. And Alcubierre wasn't planning to break that rule. He planned to bend it. Let me explain how this works. Imagine you're in London. You want to get to Tokyo. The normal way, fly for 12 hours, cross half the globe. But what if you could fold the paper? Put London and Tokyo right next to each other. You'd just step across. That's exactly the idea behind warp drive. Alcubierre said, we can do this with space itself. Compress space in front of the ship, expand space behind it, create a bubble that carries the ship along. And here's the genius part. The ship doesn't move through space at all. The ship stays still, but the space around the ship is moving, like standing on an escalator at the mall. You're not walking, but the escalator carries you to your destination. Inside the warp bubble, you're in flat, normal space. No acceleration, no g-forces. You wouldn't even feel it. So was Einstein wrong? No. The rules still hold. Nothing travels faster than light. But space itself, it can expand or contract at any speed. Sounds perfect, right? But there's one big problem. To create a warp bubble, you need something called negative energy, or exotic matter. This is stuff with negative mass. It pushes space outward instead of pulling it inward. Imagine space like a stretched trampoline. When you place Earth on the trampoline, it creates a deep dip. The moon nearby? It rolls into that dip. That's gravity. That's why the moon orbits Earth. But negative matter does the opposite. Instead of pushing the trampoline down, it pushes it up, creates a bulge. Everything rolls away from that bulge like magnets. Two same poles push each other apart. Negative matter pushes everything away in a similar way. Sounds like magic. And for 20 years, everyone thought it didn't exist. Alcubierre's original calculation showed you'd need an enormous amount of energy, equivalent to converting the entire planet Jupiter into energy, obviously impossible. The idea became a theoretical curiosity, mathematically interesting, physically useless, until 2011. Dr. Harold White from NASA Johnson Space Center announced a discovery. He was preparing a talk for the inaugural NASA DARPA 100-Year Starship Symposium. He didn't want to just repeat old information, so he did something different. He played with Alcubierre's equations, changed the parameters, adjusted the geometry. He found something interesting. If you change the shape of the warp bubble, the energy requirements drop dramatically. Instead of a thin ring, make it thicker, like changing from a wedding band to a life preserver. The result? From the mass of Jupiter down to about 700 kilograms, the weight of a car. Still a lot, but no longer impossible. This was a game changer. So what happened next? White and his team at NASA EagleWorks started building an experiment, 2012. It's called the White-Juday Warp Field Interferometer, a device to measure whether we can create tiny distortions in space. They worked for years, testing, adjusting, improving. The goal wasn't to build a warp drive. That's impossible. The goal was much simpler, just to detect very, very small distortions in space. The result? This is the controversial part. They detected a weak signal, very weak. But this is not proof that warp drive works. Many physicists are skeptical. The signal is too small. Could be measurement errors, could be outside interference. But White believes this is the first step. If this result is correct, it shows that space can be manipulated. White said in an interview, "We haven't had our Chicago pile moment yet." What does he mean? Chicago pile number 1. The first nuclear reactor built in 1942. It was built under the bleachers of a football stadium at the University of Chicago. It barely produced enough energy to power a light bulb, but it proved nuclear energy was feasible. It opened the door to the nuclear age. Warp drive hasn't had that moment yet, but the tools to measure the phenomenon are nearly within reach. Sounds far-fetched, right? But remember history. 1903. The Wright brothers flew for 12 seconds. Everyone laughed. 66 years later, humans walked on the moon. 1994. Alcubierre wrote the warp drive equations on paper. 27 years later, NASA tested it in the lab. So 60 years from now, who can say what happens? If warp drive becomes real, everything changes. The nearest star to Earth is called Proxima Centauri. It's over 4 light years away. Let that sink in for a moment. 4 light years means light itself takes 4 years to get there. Light travels 300,000 kilometers per second, fast enough to circle Earth 7 times in 1 second. And even at that speed, it still takes 4 years. With current technology, Voyager 1 would need 75,000 years to get there, longer than all of recorded human history. With warp drive, maybe just a few weeks, you could visit another star system, take pictures, come home, all within a human lifetime. But this isn't just about space travel. Warp drive research forces us to understand space-time more deeply, dark energy, exotic matter, the biggest mysteries of the universe. Some scientists think the Casimir effect might be the key. This is a weird quantum phenomenon. Place 2 metal plates very close together in a vacuum. They attract each other. Why? Because the space between the 2 plates has lower energy than the space outside. That's negative energy. It's real. We've measured it. Could we scale this up? Create enough negative energy for a warp bubble? Nobody knows yet. But people are trying, and here's what's interesting. Many technologies today were once considered science fiction. GPS, based on Einstein's theory of relativity. Without accounting for time dilation, your GPS would be off by kilometers. Lasers, from quantum theory. Einstein called it spooky action at a distance. Now you use it to scan groceries, warp drive could be next. But there's a deeper philosophical question. If we can travel between the stars, has another civilization already done this? The universe is nearly 14 billion years old. Our sun, only about 5 billion years old. There could be civilizations billions of years older than us. If warp drive is possible, if space-time can be manipulated, surely someone else has figured this out by now. And if so, why haven't we met them? This is the Fermi paradox. Physicist Enrico Fermi once asked a simple question: so where is everybody? The universe is so old, so vast, life should be everywhere. Advanced civilization should be everywhere. But we see nothing. No signals, no visitors, no evidence. Maybe warp drive is truly impossible. Maybe there's a barrier we can't see yet. Or maybe they're already here, and we just haven't recognized them. 1966. Gene Roddenberry created Star Trek. The USS Enterprise flew with warp drive. It was pure fiction, a storytelling device. Nobody thought it could be real. 2011. NASA began testing similar technology in the lab. The line between science fiction and reality is fading. We may not live long enough to see real warp ships, but the next generation, our children and grandchildren, they might look back and say, that's when it all began. Right now, somewhere, a graduate student might be working on the breakthrough, the Chicago pile moment for warp drive. Or maybe that breakthrough is still 100 years away, maybe 200. But the fact that we're even trying, that's remarkable. Humans have always looked up at the stars and wondered, what's out there? For most of history, the stars were completely out of reach. Now we're not so sure. The only question is, do you believe?